Okay, let's keep going. This is the next part. This is the stores that we're going to look at next. Like we have a grid that just shows the whole table. So you already know the SQL statement associated with it. I'm 100% certain. So we look at query stores, we drop another query, and we double click on the query, and we select star from stores, we execute the query, and there's all the stores. Honestly, the most work with this is entering all the stores with country code and domain. That's literally the most work I had with this. Select stores. I have a data source for those as well. And then I go to the storm form. And there we go. We have a navigator and we have a DB grid. And the DB grid has a data source again associated with it, which points hopefully, and it does, to DB manager source stores. And in order to get the fields, we right click on the data set and select not query editor. We select fields editor. And then here we have the fields associated with these stores. That's it. There's no magic with the stores. We then have the list of stores. We can add stores using the application, and that's it. Something I have not explicitly pointed out, of course, the database IDs and everything are maintained by FireDAC and the database server automatically. So looking at the actual data in the database, looking at the actual data inside of the database, if we look at the books, for example, there is the ID, which is managed by the database server that you use. In this case, SQLite. And we also see I haven't updated this yet. So if I press, what is it, F5 or F9? No, how do I update it? Here. This is, Command R. That's how I update it. Okay. So here we have the record that we added in the last video, Holger's next book. And we also see that I haven't assigned a cover yet. Cover is null, and publish, description, and so on. So let's say we look at editions. And in editions, we also have added to, see, there's the color, there's the hardcover, and the book's ID, and this is what I wanted to point out, is also being managed and added by FireDAC. And this is also the reason why it's advisable to add the field that FireDAC has to modify for this. So in case you missed this, if we go to the editions here, the detail field, book's ID, that's the reason why we need the detail field in order to give FireDAC the chance, hey, which field do I need to basically add it to add the reference to the other record from the other table. Now to the most difficult form of all of them. I'm honest. And this is not something you write down without having a notepad next to your computer. And especially like me, I'm not that versatile when it comes to SQL statements. I'm pretty honest about that because I grew up in a developer generation that constantly uses object relational mapping, and we already used a lot of objects. Instead of storing everything in databases, we used a lot of data structures. So these kind of things with multiple joins, they always screw with my head. I'm quite honest about that. And with that in mind, I said the difficulty with this dialog is that I don't store a list of all the stores that it is available in. No, instead I store a list that it's not available. So this list is actually a negative of what's in the database, if you think about it, right? So if we go to the hardcover here, this lists all the stores because it's available everywhere. But if you go to the color edition, for example, it's missing these two because these two are listed in the unavailable table. And this is what we have to model now, how our user interface needs to react. Like if it's in the database, we don't want to check it. And the tricky part is if we check it, like for example, let's say the hardcover edition is available in Canada now, the database needs to be updated. So if I go into the database now, we should have one record less in the unavailable table. So right now we have 5 records. And if I update this, See, Canada has been removed. We only have 2 here now. And as soon as I check it again, Canada doesn't have it. We should go back to the database and I update it again. There's the record again because it is indeed not available there. So that's the behavior that we have to implement. And we also have to implement the queries that manage all that. And first, we go into the database manager and look at a special query, which gives us all editions. So let's double click here, execute. What I do here is I just get a list of all the editions, which lists all the editions and then links the book. So I have, for example, here, the paperback edition ordered by title. That's also the key. So I order by the title here. So cross-platform is the first one, and the edition is the paperback edition. And in the grid, I want to use this long title, cross-platform, which combines title and subtitle is grid title. So I want to combine these two so I have a nice grid. So this lists from the editions and adds the information about the book. I don't know if that is something you consider good user interface or not. So if we look at this in detail, so if we look at the books again, so for example, we have Holger's next book, that's what we created. We have a color and a hardcover. And if I now go over to the availability, I need to basically look at the availability of the editions. So I need one row in this grid for every edition. Instead, I also could have done book again, edition again, and then the grid. So this is just me compacting 2 tables into one so that you only have one grid. That's the trick here for this user interface. If you ever want to use this, this is a viable approach how you can do these things, that you have one line, which is, and basically the relationship is flattened into one table. So instead of having like one record in the book table and then 2 in the edition, for every edition, I have one row in my query with the book table. That's what I'm doing here. So instead of having like 2 grids, one grid for the book and the next one for the edition, I have one grid that allows me to select things quickly. That was the idea behind this. And now looking at the query in detail, what I do here, again, I have to move these things over because they're always reserving the maximum space. We simply select from editions, all editions, and we left join the books, and we look that the book's ID equals the ID of the book. The book's ID inside of the editions has to match the ID of the book in the books table. That's all I'm doing. So you get, on the left, you get all the different editions, and we add the title of the book and everything on the right. That's all I'm doing. So this is the data for the grid, and I order by title and subtitle. So if we look at the grid, we have source all editions, which points to all editions, and the form or the availability will most likely here go to DB manager source all editions. Okay, so that's the interesting thing. You might see there's a second data source on this form. It is important, but note that it says source editions, and this is source all editions. So you might suspect something going on here, that the difference, this is subtle difference, is important, and it is. So, and the DB manager here, query unavailable stores. You go here. We have execute. So for what we do here is we select the ID from the stores. So we get a list of IDs for the stores. That's the main important thing. So it's basically Canada, Japan, Australia, Germany, the ID from that table, but we join the unavailable, meaning we only want to see those that are listed in the unavailable store, where the store ID equals the ID of the store, because remember, let me go here, the unavailable table here is a tuple with the store ID and the edition ID, meaning if it's listed, it's unavailable. So in order to only see the stores that are unavailable, we have to do the join, basically join them in. So we get the unavailable stores by selecting the ID of stores of this join. And also for one edition only, where this ID is coming from. At runtime, ID will be filled from the master table because we have a master detail relationship between query unavailable stores and the query all editions. So we look in the options here, in the parameters here, and here is ID listed, and I simply set the value of 8 manually for testing, because I knew that my book number 8 has stores 10 and 12 unavailable. That's me setting it for testing, okay? So that is how I can test things at design time as well. And then I have 2 commands, and I literally was very strict here. I implemented it using FireDAC. I didn't use strings or anything. We need to add to the unavailable table, and we need to remove from the unavailable table. So add to the unavailable table, it means insert into unavailable with a store ID and an edition ID these 2 values. That's how you add to the unavailable table. And you remove from the unavailable table, delete from unavailable, where store ID equals store ID and edition ID equals edition ID. And these are not queries. These are TFD commands. These are a component that is used if you don't need a result and just need to send a command to the database server. You can use TFD command. You might argue we use TFD query and just use the method exec SQL, and I won't argue with you. You're not going to get an argument from me. It's just as good, but the command has actually been designed for this, that you just execute a command for that. And so I used the commands here. And now the final step is, how do we bind the user interface? How do we show the checkboxes? That's, I guess, the interesting part now. So let's tackle the user interface. And again, this is the most complicated user interface you'll encounter in this example. So we have a list of our editions. We looked at that. Yeah, we added the columns. All very easy. But here, there is no TDB checkbox, and we have to do this in a more generic way because only the checkboxes are enabled where we don't have a store that's listed in unavailable. That's the functionality that we need to have. So what we do is, let me explain it from scratch. When we create the form, we set up the data sources. Same kind of thing that we have seen with the other tables. We remember the query for the all editions. I store a reference to that. So f all editions here is literally a reference to that data set. So I store that. It's just a reference, not a copy. Very, very, very important. It's a reference, not a copy. So if you make changes on f all editions, it affects the query that's on your data module. It's the same query. Same for the editions. Basically, the data set. This is the trick here. The source editions data set. So the data set for this data source here is the one that points to all editions on your data module. So f all editions is used as the data set for this data source. Okay? That's very, very important. And then the stores, again, I store the data set for all stores. I will also store a data set for unavailable stores. Okay? And again, very important. So the f all stores is TDB manager shared query stores, and f unavailable stores is TDB manager shared query unavailable stores. So what does this give me? Well, it gives me the comfort of working with these field variables instead of writing this all the time. That's it. It's just making your code more readable. That's it. I could have written each and every time TDB manager shared query stores instead of f_all stores. That's all it does, because there isn't any data that's being copied or anything. It's the same thing. And then these two lines. f_on_old after scroll equals f_all additions after scroll. So after scroll is an event that gets triggered when you scroll inside of a data set, right? So f_all additions, if we look that up, points to query all additions. What that means is if we navigate in this data set in code or even inside of your user interface, there's events that are being fired. And the after scroll event is fired after a scroll takes place. So let's say you call query all additions.next. The next record is selected, and then after scroll is called. So you're actually on the next record already. Okay, that's important. For some other reasons you might use it. I don't know if it's important here, but basically for us here, the main thing is we want to find out if we scroll, if we get to another record. That's very, very important. Why is that important? Because if we look at this dialog, we need to update these checkboxes as soon as a scroll takes place here. So what we do is we say the after scroll event is on after scroll, and on after scroll is a procedure in this form, in our form of else form. That means we modify it. And whenever you do something like that, you have to restore the state that was there before your form was opened, if you reuse that kind of stuff. Another scenario would be you create a copy, you duplicate the query, or you have the query on your form here and execute the query. Also good. And you don't need to basically add the event to a query that's on another data module. But this is just something I wanted to show you, that you can define your own events in code in Delphi. You don't have to set everything up at design time and copy paste things just so you have the events to the data set that you want to use. So here we hook up the on after scroll to the on after scroll method that's on this form. And before you do that, you remember the old reference. That's the thing. Most likely it's going to be nil because we haven't set it to everything. Why I point this out in such detail is, let's assume you leave this out, and when the form closes, so when the form closes or whatever happens to the form, when the form gets destroyed, you don't restore that. What happens is that the IDE tries to, not the IDE, that the VCL tries to execute your after scroll event. The reference is still tied to the dataset. The dataset is still there when the form is gone, right? And that will cause your application to crash. You get an access violation because you have a reference to a pointer that's no longer valid. So you have to make sure that when your form gets destroyed, you reset the event to the value that it had before your form was open. Why does this work here? Because we have modal forms. So we can basically, at this moment, the on-scroll event is flipped, and it's the on-scroll event on our form. And as soon as I destroy the form, which happens when I close this form, because it's a modal form that gets freed, our after scroll event has been the default that it was before, meaning no event. If you have an application that has multiple windows open, you need a different solution. Then you only can do basically one query for every form, for example, because each form shows its own data. This only works if you have modal forms that you don't have different views on the same data. With that being said, that concludes the setup data sources, but now this reopen here is also very important. It's something that I noticed. If you were a keen watcher of the video, you might have noticed we added books and then we went to the editions, and the editions didn't appear of the book that we just had added. So the thing is, you have to reopen dependent data sets that run queries on the database server in order to keep your user interface current. So what I do here is I just basically close F unavailable stores and reopen them. That's the only thing that I do here to make sure that the information that we have is accurate. And with that, our form should be, if I see this correctly, let me go into the events, form create, go into setup data sources. With that, we have everything current, and then we can update the checkboxes, because with that being the case and the database being open, we have now basically in the upper grid, we have our basically additions, and now this is empty. And we need to update the checkboxes that they reflect the state that is inside of the database. So in update checkboxes, first of all, we need a bookmark, and the bookmark remembers the position that we have in all stores. That's so if you were navigating before in all stores, it remembers a bookmark. I only do this here once, especially when we do the markdown and the JSON export. I do not remember the position inside of all the queries. That is something that you could add later on. This is just one place to show you how it's being done. So first of all, we disable all the controls that you don't get flickering and all that kind of stuff. And the bookmark gets set to where you are inside of all stores. And in the end, you go back to the bookmark, which is something I actually forgot in the code here. So good thing we looked at it. So we do F all stores, go to bookmark, bookmark, and then you have to free the bookmark. That's also very important that you free it. And then you enable the controls again. That has to be in a finally, because otherwise you wouldn't see any result, or you would navigate in the grid, but nothing would happen because the disk controls are disabled. And also, we do the same kind of thing, like disable controls with the items of stores. Stores here, if you look at it, that's the checkbox list. And in there, if we call begin update, that means that the user interface is not getting updated constantly. It's updated the first time when we call end update. Then everything is updated only once. So instead of updating it as many times as we make changes to the checkbox list, we update it only once. And how many times, what needs to get added to the checkboxes? We need to iterate all the stores. We start at the first store. That's why we say F all stores first. And then we get the index of the name of the store, and as an object, we store the ID of the store inside of our checkbox list. So let's take this a little bit apart more, because a lot of Delphi developers forget that add object returns actually an integer that designates the item that was added. So with that said, so we could say something like stores.items.add text, right? That's how you would add something to the checkbox list. That would end up being text, and then on the left you would have a checkbox. With the command here, you add the name of the stores, because F all stores, let me show the data set again. F all stores, here it's this one, query editor, execute, is a list of all the stores. So we literally get United States, United Kingdom, Germany, France, Spain, Italy, Netherlands, because we need all stores, right? You need to be able to check or uncheck from the whole list. So it doesn't suffice to filter there. So all the stores, and then you need to determine the state of the checkbox. But before you do that, you need to remember which record is associated with that store, because the index, for example, index 0, doesn't have to be the ID, especially if you order by name of the country, doesn't have to match the index inside of the checkbox list. So for that, we add an object, and that is the thing that is so magic about the Delphi compiler. You can simply cast to T object, even if it's just an integer. And we cast the ID, which is an integer, of the store and add it to the name as an object. So that means, in addition to just having the name, you also have the ID of the record inside of the database. So you store not only, if we look at the data, what it looks like in concrete, if you go to the stores, you do not only store United States on this checkbox, in addition, you also have the ID 1. And that's important because the first entry, United States, in the list would be 0. L index, our L index here, is 0, not 1. And that's why you have to store the ID of the store as well. And then we can say the check state, if it is unavailable, is, and let me scroll down a little bit here, in the unavailable stores, we have to locate the ID field. And if it matches the ID of the current store that we're looking at, meaning if it is found inside of the unavailable stores, that means it's not available, so it shouldn't be checked, right? So it should only be checked. And what should be checked? L index. That's the index of the item that was added to the checkbox list, not the ID of the record. It's the index that was just added. So that state should be switched accordingly, and it should only be checked if it is available. So the state is not L is unavailable. Okay, this is how we can iterate all the different stores. We iterate all the stores, and what we do, one more time, we add the name, and as an object, we add the ID of the record, and this method returns the index inside of the list. And we need that index in order to set the checked state of that item. And the checked state of that item is determined if the store, this time we look by the ID again, is found in the list of unavailable stores. If it is found, it's not available. If it is not available, it should not be checked. It should only be checked if it is not unavailable. That's the loop that we will use in order to populate the checkbox list. And the final piece of the puzzle is that update checkboxes needs to not only be called after the form is being shown, it also needs to be shown when we navigate, right? So if you look at the implementation of on after scroll, we simply call update checkboxes. And that's the whole form, almost. So the final piece that is missing, of course, is that we click on the checkbox and our data set needs to be updated, because let's look at the concrete example if we run it. So now if we navigate, you see it flickers one time. And now if you go to the color edition, Japan and Australia lose their checkbox, because these records are found in our unavailable data set. But if we now check Japan, meaning we click, then we need to send an insert statement to the database and update the checkboxes so that it's checked. That's fine. And that's exactly what we do. The click check event has a method, toggle store avail, and toggle store away and toggle store avail, not away, it's toggle store avail, has basically two implementations. First of all, we find out if it is checked or not, what has been clicked. We find out what has clicked. So it might seem trivial at first, but if you read stores checked at this point after the click, the checkbox has already flipped. And that took me like one implementation. I was like, no, it's not right anymore. So let's say, look in here, and Japan is not checked right now. So if I click it, the moment we're in toggle store avail, it's already checked. So in order to get the state unchecked, in order to check it, you need to invert it. And this is exactly what I do here. I say not stores checked. So the var store ID is now the ID of the store record. And I get that by reading from the objects of the item that has been checked and then cast it to integer. And that is the ID of the record. And then the addition ID, I can read that because it's selected in the grid right now. The addition is selected in the grid. So I can use the ID field of that. So I have my two variables that I either need to remove or insert into the unavailable table. And then I say if it is not checked, meaning we need to remove it. So we call TDB manager shared remove from unavailable, L addition, L store ID. And if we need to add it, we say add to unavailable. And these methods do nothing but basically remove from unavailable, uses this command, either remove unavail or add unavail, and parent by name adds the variables a addition ID and a store ID to the parameters store ID and addition ID respectively, and then basically call execute. That's what executes the command. And this is for remove, and we have the same for add. Same thing. I could have refactored that even more by passing the command as a parameter, because both times the same parameters get changed. So I could have passed the command as a parameter and only implemented it once to optimize it even more. And with that, I have to reopen the data set, of course, because the select query wouldn't know that changes have taken place because it's a different query, right? So I reopen my unavailable data set, and then I call update checkboxes. The same addition is still selected in the grid. So then the update will actually happen based on the records in the data set. This is very, very important. Imagine you use a different database. Imagine you don't use a file-based database and your database connection went away. You don't know that. So I click on Japan now, and if I were just to assume that my database has been updated and I just do, oh yeah, checked, it's true now, done, and send away the command to the database, but do not actually build this checkbox list now based on the database, I would actually have different data in the database than the data that's shown in the user interface. Not good. So I literally close everything and then rebuild the checkboxes based on the state that's in the database now. I think that's a very important thing to do in this case, because I don't want to do, obviously for my books, it's not, I wouldn't have any major consequences, but like you want to show what's in the database. You don't want to show what's you assume is in the database, right? So that's the behavior of this checkbox list. You might argue, well, you update the whole list, but I think it's a good compromise for having current data shown in your user interface. So with that, we have the whole data stuff covered. You have written a user interface that shows books, stores, and then uses a cross table to show if a certain edition is available in a certain store or not. I think that concept in particular is very, very useful for projects that you have. If you have categories or something that is attached to a certain thing, these kind of user interface things where data is stored in a certain way, where there's just numbers and IDs in the database, and the user interface gives you the comp part of a checkbox or a list box or something like that. This makes this example very interesting, in my opinion.